First and foremost, if you missed last week, you should be able to go back to my website and under last week's work, you'll see where it says notes, and it sums up everything that we did last week with the study of trigonometry. Trigonometry is the study of right triangles and their relationships between any two sides and their angles. It's probably one of the most useful bits of math that you can do. Everything from construction to music are all tied to trigonometry. It's also even connected to some physics stuff. I've seen Mr. Liu drop some of this stuff down on you before, and hopefully my goal is to make some sense of this. For any right triangle, you have something known as a reference angle. That reference angle is often referred to as theta. That's that circle with a line through it. Sometimes it's a capital letter, capital A, B, C. Maybe it's a lowercase variable, X, Y, or Z. But based on this reference angle, we're able to label three major sides. They are the one that's right across from that reference angle. So if I shot an arrow across from it, that'd be my opposite side. From the Pythagorean theorem days, we have hypotenuse. Remember, hypotenuse is my longest side if I busted out a ruler. It's also across from that 90 degrees. Last but not least, the only other side is your adjacent side. Adjacent means next to. Theta is next to that adjacent side. My hypotenuse is also next to theta, but hypotenuse, first and foremost, is my longest side. Adjacent is technically in between my theta angle and my 90 degrees. This changes, of course, if your perspective changes. So if theta is up at the top of my picture, for my second example, shoot an arrow, look at where my opposite is now. It's on the bottom of my picture. My hypotenuse is always going to be my longest side with the ruler. And then last but not least, the adjacent side is between my angle, theta, and 90 degrees. I gave you two other examples of what this may look like and use that to help you out. With trigonometry, what we did is we came up with a mnemonic device that is seen all over the internet if you look this up. Something called SOHCAHTOA. SOHCAHTOA is fun to say, and it's a way of remembering three major ratios: sine, cosine, and tangent. SO stands for sine and opposite over hypotenuse, SOH. Ka is cosine, adjacent over hypotenuse. And then TOA, T is tangent. O is opposite, A is adjacent. TOA, tangent, is opposite over adjacent. By just saying SOHCAHTOA over and over and over again, we have a better shot of getting this stuff down rather than having to go back to our notes. I have some examples to put some meaning on this. So here I don't have a theta, but what I have is a question mark. My goal is trying to figure out what that angle is. The way we do this is we focus on that angle, and I'll shoot an arrow across. The side across from that angle, again, is known as opposite. Now, while 29 is a big number, 29 is not my longest side with a ruler. That would be this one right here. The one without a number is my hypotenuse. But you know what? Because there's no number or no letter there, I'm not going to write hypotenuse there. There's no point. So if my hypotenuse is blank, no need to write it down, and I know what my opposite, 29 must be my adjacent side. This is the side that is next to my angle and my 90 degrees. So why would labeling all this stuff make a difference? Well, at the beginning, we told you about the mnemonic device SOHCAHTOA. And what we're trying to do is we're trying to find the function that has both opposite and adjacent at the same time. So when I say SOHCAHTOA, I'm looking for what has O and A at the same time. So only has opposite, not adjacent. Ka has adjacent but not opposite. TOA. TOA has opposite and adjacent at the same time. So this is how we know to use the function tangent of the angle. Tangent is opposite over adjacent. And what I'll end up doing now, instead of writing these words, I'm going to try to fill in as many numbers as I can. Tangent of theta, which we don't know, is my opposite side, which is 14, and my adjacent side, which is 29. And then my goal right now is to get theta by itself. I want to know what that angle is. Last week we stopped at the fraction, and part of trigonometry is just writing that ratio. However, this week what we want to be able to do is figure out what that angle is. How big is that angle if I know what these two numbers are? Especially say if I don't have a protractor where I'm able to measure these angles out. So the way we do it is we start thinking about how math is, and everything in math, specifically algebra, is a game of opposites. What does that mean? Well, my goal is to get rid of stuff. The opposite of times is divide. The opposite of subtract is add. Hell, if there's a square on this, I would take a square root. But the opposite of tan is something known as tan inverse, tangent inverse. And all that is that trig function of tangent with a -1 as an exponent. Now, if I do something on one side, I do it to the other as well. So the opposite of tangent is tangent inverse. And all it is me writing that tan -1 on both sides. These opposites cancel, and I'll just write the letter theta. And then what it says here is tan -1 of 14 over 29. And what I need to do with this is something I actually type into a calculator. So pulling out the decimal scientific calculator, if I had a regular scientific calculator, to get the inverse, because I see tan right here, to get the inverse, I would press the second key and then tangent. Here, I'm going to press function, now press tan -1, back to main, and go 14 divided by 29. I want you to notice my answers on the other side, and it's a messy decimal. Not everything comes out nice. And it really just depends on the work that I ask you or whatever's given to you. It's the rounding issue. I'm not going to write this whole thing. So I'm going to look at this as a decimal to maybe one place. 25.7. Look right behind that 7. It's a 6. That 6 is going to move that 7 up. So 25.8. degrees is one answer. But I don't know about you, but sometimes some people, I rarely hear about 25.8 degrees. Usually degrees are always whole numbers. You never hear about them as a decimal. So if I go back to 25.7 and say forget the decimal, let's round to the nearest whole number. 25.7 wouldn't stay at 25. It would go to 26. So this is rounding my answer to either a decimal or whole number, depending on what's asked of me with any of the work that I ask you guys to do. Okay, let's take a look at another example. But again, I want to remind you, we labeled everything. We figured out what trig function we were going to use. And then to add on to last week's work, we did the inverse of the function, which is just writing the -1 next to each one and typing that on a calculator. Next example. Here's my reference angle, referenced by that question mark. Shoot an arrow across. That's my opposite side. I look at 24. 24 is right next to the question mark, so on one end it's adjacent. But if you look at it, this is my longest side. My triangle's kind of rotated a bit, but I know for a fact that's my longest side with a ruler. So that's my hypotenuse. Knowing these two things, I'll write so, ka, toa. A little sloppy, but that's the heart of what we've got. And what I'm trying to do is I am trying to look for which of these three terms, sine, cosine, or tangent, that's what so, ka, and toa stand for, which have opposite and hypotenuse at the same time. Take a moment. Yes, you are correct if you were thinking about it. So has the letter S, but I'm looking at the other two letters, O and H. I'm looking for the letters O and H at the same time. While ka and toa each have one of those letters, I'm looking for the one that has both. So what has opposite and hypotenuse? Sine. So I'm going to write sine of my angle, I don't know. And I could write x, I could write whatever. I just want to get used to writing theta. Is opposite over hypotenuse. Now I'm going to replace it with the numbers. My opposite is 12, and my hypotenuse is 24. And I start thinking back to some of the work that we did last week. And I had referenced to you, we don't need to reduce. Like, look at 12 over 24. You can simplify that mess. You can make it smaller. And if you want to, you are more than welcome to write it. If you aren't aware, the answer is 1/2. But what's cool about this stuff is you actually don't need to reduce it. So especially if you have really big numbers, it really doesn't make a difference because it's a ratio and all the answers are going to be the same for whatever set of numbers. How do I undo sine? Just like tan, I wrote tan inverse. For sine, I write sine inverse. Sine in the -1 is read as sine inverse. Some people also call it an arc function, so arc sine. These cancel, and I just write theta. And I get sine -1, and remember that's part of my function, and 12 over 24. If I did this for 1/2, I would get the same answer. I'm going to type this one on a calculator. Pull up my inverse function. Make sure it says -1, because if you do the regular one, you would get a different answer. So sine -1 was 14 divided by 21. No, it was 28. And then if you take a look at my answer, it's 30. Sometimes they turn out to really nice whole numbers. So sometimes things turn out okay. And again, this is something that if we were at school, I'd measure all this stuff out and show you that it actually works. Let's take a look at one more case. Last example. Shoot an arrow across. That's my opposite side. But because there's no number and there's no variable there either, I'm not going to write anything. But that would be my opposite side. So since it's my opposite and there's nothing there, let's not write it. And what that forces is the other two sides to be adjacent and hypotenuse. Which one's my hypotenuse? That one's not that bad. That's 20. Why? It's my longest side. So 13 has to be my adjacent side. It's the side that is between the 90 degrees and the reference angle. SOHCAHTOA is my mnemonic device. Excuse my poor handwriting. And I'm looking for what has hypotenuse and adjacent at the same time. Hypotenuse and adjacent, hypotenuse and adjacent. SOHCAHTOA, SOHCAHTOA. What has both? H and A. Now, even though I don't see H and A in that order, Ka has A and H, those two letters. The order of my picture doesn't matter, but having both those letters is what makes the difference. So what has hypotenuse and adjacent? So, no. Toa, no. Ka has A and H. Ka stands for cosine. Adjacent is 13. My hypotenuse is 20. Now, I want to save you guys some time as well. If you realize that all we did at both sides of those previous examples is when I had sine, I wrote sine -1 on both sides. When I had tangent, I wrote tangent -1 on both sides. So if I have cosine, I'm going to put cosine -1 on both sides. So what I'm going to end up doing is I'm just going to write this out without writing cosine inverse on both sides. I'm just going to make it cancel on the left side, which makes it disappear. But now I'm going to write cosine of -1, making sure I write that inverse so I know I typed this in properly. So now, let's type this on a calculator. Again, if I had my old calculators at school, I would press second and cosine. Now, we're going to press function, cosine -1. And again, my numbers were 13 and 20. So 13 goes first. And I get 49.45. Again, the issue is how they ask you to round. They ask you to round to the tenths place. You're going to look at 49.4, and then you'll look right next to that. 5 makes it go up. So it would be 49.5. Or, if I look back at this, say I didn't want a decimal, I look at 49 and I look at that 4 next to it. The 4 is not going to make the 49 go up, so 49 degrees. Why am I writing 2 answers? You don't have to write both answers. I will take anything if we were on a worksheet or anything else. But 49.5 is rounded to the tenths place. That means 1 place past the decimal. Or if you don't write the decimal, this is rounding it to the nearest degree. This is also known as rounding it to the nearest whole number. So I hope this is an introduction in terms of you figuring out what you need to do for finding the inverse of a function and using it to figure out a missing angle. Label your sides. The 2 sides that have numbers, you look at those 2 labels and say to yourself, so katoa. Whatever has both of those is the function you use. Here we had ka has adjacent hypotenuse, so we wrote cosine. And in that order, adjacent on top, 13 on top, hypotenuse on the bottom. The opposite of a trig function is its inverse, which is written with a -1 next to it. And then we typed it in a calculator. Depending on the work, if they ask you to round it to the tenths, 1 place past the decimal. If they ask you to round it to the nearest degree, round it to the nearest whole number. Okay, you know me, I'm always available through email and other things. Hope you guys are doing well. Thanks for this experiment, and we'll go back to Zooms next week.